Hello people, welcome to module 9 of Basics of Engineering Mechanics. In this module we will be learning how to express 2D and 3D static equilibrium equations. We will recognize and apply the principle of transmissibility and we'll explain the relationship between the sums of the moments. Okay, so let's start. So in the static equilibrium equations in vector form, if you have a body over which sum of all the forces is equal to 0 and you have at the same body there is a particular point P out which the sum of all the moments equal to 0, so that body is said to be in static equilibrium. Now suppose in two-dimension case we take a body on I and J axis, and this body does not have any static acceleration, linear acceleration in x direction, so that means ax is equal to 0, and it does not have at the same time any acceleration in y direction, so that gives us the sum of forces acting on x direction and y direction equals to 0. Now at this body, at any point, that point can be here, or the origin, the sum of moments about that particular point should be 0, and that gives us the static equilibrium form. Okay, now in two-dimension cases we have three simple equations that gives us the static equilibrium. That means first of all it has to have summation of all the forces in x direction equals to 0, summation of forces on y direction equals to 0, and summation of all the moment about a particular point P, that P is any arbitrary point that we choose, should be equal to 0. Now if we talk about 3D, the equations changes to 6. Okay, in 3D we will be having 6 different equations, because now we have moment not only in towards the z axis but about x and y axis also. So we'll be having sum of forces in x direction, y direction, and z direction equals to 0. That is first case. And some of the moments about x axis, about y axis, and about z axis, that has to be equal to 0. So that is the form of static equilibrium equations. Okay. Now we will talk about the principle of transmissibility. The principle of transmissibility says if there is a body over which you apply a push force, then if the same force of the same magnitude is applied as a pull force along the same line of action, then that does not change anything externally. It might be changing things internally, but since we are studying the engineering mechanics which deals about with the rigid bodies, that means we don't have to worry about what is happening inside the body because of this transmission of force. Okay, so this is the basic principle of transmitting. You can take any force and you can transmit it along any way, but it should be having the same magnitude and the same line of action. So that is the principle of transmissibility. Now, the relationship between sum of moments, it says if the body is in a static equilibrium, that means it has sum of forces equals to 0, sum of the moments about any point P is equal to 0, then if we take a moment about any arbitrary point A, that point might be in the body or might lie out of the body, that has to be equal to 0. So that is the relationship between the sums of moment. If there is a body which is already in a static equilibrium, you can take the moment about any particular point and that should be equal to 0. Okay, so there is an example we will be looking in future modules. So this example says, suppose there is a summation of forces of body is equals to 0. Okay, and the summation of moment about this point P, particular point P, is equal to 0. So hence this body is in static equilibrium. Then summation of moments about point A, that is point A here, point B, and point C, which is lying somehow suppose outside the body, that will all be equals to 0. Okay, so that is the end of this module. Thank you so much.